In this video, we're going over a binary search tree iterator. So implement the BST iterator class that represents the iterator over the in-order traversal of a binary search tree. So in our constructor, we're giving the root of a binary tree, and then we had to implement the methods hasNext and next. So for the hasNext, basically checks if we still have another element in our current in-order traversal. And then next just returns the next element in line in our traversal. So in our first example, we're given this tree. And then we call the next method, which basically returns the first element in our in-order traversal. So we start here because in-order traversal is left, root, and then right. So we get 3 first, and then we return next with the next element 7. And then we call hasNext. Since we still have elements here in our traversal, we have to return true. And then next goes to the next element, which is 9. So we return 9. We check again. Yes, 15 is next. And then we call next. So we return 15. And then we check if there's still more elements. Yes, 20 is still left. So we return true. And then we call the next element, which is 20. After we return 20, it check again if there's still more elements. Since we finish our traversal, we have to return false. So let's go over the thought process. So let's first go over the straightforward approach. We can perform a recursive in-order traversal and store all of the elements inside a list. Then we can use the list as our iterator by keeping track of the current elements, or keeping track of the index of the current elements. Now this approach will cost us O of n time complexity, or time complexity and space complexity. So initial time complexity and O of n space complexity. And then the methods will have O of 1 time complexity. Now we can reduce the space complexity if we implement an iterative approach. We implement an iterative in-order traversal instead. We can reduce the time complexity or the space complexity to O of h if we implement an iterative in-order traversal. We will be keeping track of the current nodes inside a stack instead. Now let's go over the pseudocode. So we're going to create the following variables, or the following fields. It's going to be a stack. It's going to be a stack to keep track of the nodes. Now in our constructor, we're given the root of the tree. We want to initialize the stack or the field, and then want to push roots and all of the nodes on the left path of roots into the stack. In this case, we're performing our iterative in-order traversal. And then the next method we want is the next method. Now we want to pop a node from the stack. Now I want to push node.right and all of the nodes on the left path of node.right into the stack. Then we can return node.val, or the value inside the node. And then the next method we need is hasNext, which all we need to do is just check if our current stack has nodes or not. So we return true if stack is not empty, else we can return false. Now let's go over the time and space complexity. In our iterator, our space complexity is O of h, where h is the height of the tree. This is our stack. And for the next method, the time complexity, the worst case is O of h, because we're pushing the left path of each node, as we can see here. O of h pushing left path of each node. And then the average case is going to be O of 1. And then our hasNext, the time complexity is going to be O of 1, because we're just checking the stack is empty or not. Now let's go over the code. So we're going to first create our field, which is our stack, which contains nodes. We're going to initialize our stack in the constructor, and then we're going to push all nodes on left path. Pass in the roots, and then we can create this method. And then we're going to go do the left path. So for tree node is go to roots. Node is not equal to null. We're going to move down our left path. And then we're going to push into our stack. Push in the current node. Now let's first go over the hasNext method. So we're just checking if our stack is empty or not. So if the stack is not empty. If the stack is not empty, which means we still have nodes to process. If the stack is empty, we have no more nodes. So we finish our in-order traversal. Now we implement our next method. We have to pop a node from the stack. Now I want to push all of the nodes on the left path of node.writes. This is to implement our iterative in-order traversal. And then we can return node.value. Let me know if any questions in the comment section below.